Hi everyone, my name is Lourdes and I'm here to discuss about McLeod gauge. McLeod gauge is also known as a McLeod vacuum gauge. It's a type of pressure measurement device primarily used to measure low pressures, typically in the vacuum range. It operates based on the principles of Boyle's law, which describes the inverse relationship between the pressure and a volume of a gas at constant temperature. So let's talk about the principle of operation. So Boyle's law, according to Boyle's law, the pressure and volume of a gas are inversely proportional when the temperature is kept constant. In other words, as the volume of a gas is reduced, its pressure increases and vice versa. So the second one is technical design. The McLeod gauge consists of a glass tube with a mercury reservoir at one end and a graduated scale on the tube. The tube is closed at one end and connected to the vacuum system at the other. A small volume of gas is trapped in the sealed end of the tube. By raising or lowering the mercury reservoir, the volume of the gas is changed. The pressure in the vacuum system is applied to the gas in the sealed end of the tube. The pressure is inversely proportional to the volume of the gas as per Boyle's law. So the third one is measuring process. To measure the pressure, the mercury reservoir is raised, which decreases the volume of gas trapped in the sealed end of the tube. As the volume decreases, the pressure increases due to the Boyle's law. The pressure can be read directly from the graduated scale on the McLeod gauge. The gauge is calibrated to provide pressure readings in torr or other vacuum pressure units. So let's talk about the types of the McLeod gauge. There are different designs and modifications of McLeod gauges, but they all rely on the basic principle of Boyle's law. Some common types include the simple McLeod gauge, precision McLeod gauge, and combination McLeod gauge. So the materials used of the McLeod gauge is typically consists of glass for the tube and mercury for the reservoir. The glass tube is used because it is not significantly affected by pressure changes in the vacuum range. Mercury is used in the reservoir because of its high density and low vapor pressure at room temperature. So the measuring range of the McLeod gauge is primarily used for measuring low pressures in the vacuum range. The range can vary depending on the specific design and size of the gauge, but it is typically used for pressures in the range of 10 to the negative 3 torr to 10 to the negative 7 torr or even lower. So let's talk about the limitations of the McLeod gauge. The first one is mercury safety. So mercury used in the McLeod gauge is toxic, and its use poses environmental and health risks. Proper handling and disposal of mercury are necessary. And the second one is limited range. McLeod gauges are not suitable for measuring high pressures as they are specifically designed for low pressure applications. So the third one is accuracy. The accuracy of McLeod gauges can be affected by the temperature fluctuations and the need for precise adjustment of the mercury reservoir. So the fourth one is glass fragility. The glass components of the gauge can be fragile, making them susceptible to damage, especially at lower temperatures. The fifth one is size and weight. McLeod gauges can be bulky and heavy, which can make them less convenient for some applications. The last one is maintenance. The maintenance of McLeod gauges can be more complex compared to other pressure measurement devices due to the limitations and environmental concerns associated with the use of mercury. Alternative pressure measurement methods such as capacitance-based and ionization gauges are becoming more common in modern applications.